We're Team Design Devils, and this is Band in a Box project. I'm Brad Meadows.
I'm Sean Kessler.
Jocelyn Carl.
Jeremiah Brooks.
Today, we have identified a problem statement. Budget and limited cargo space have rendered the band Maroon and Gold's 4 current instruments obsolete. The band needs 4 instruments designed to play a song during their upcoming tour. Below are some listed design requirements. Some design requirements include cost, instruments, the type of instruments, notes, size, and material. The specific constraints are listed down below on the slide.
The design criteria are weight, function, material, creativity, size, cost, and aesthetics. They're compared to decide which is more important using an AHP table.
The main priority of our design goals is to ensure that our instruments play all the notes for the song ASU Alma Mater, and each instrument can play its specified voice. The materials must be cost-effective and readily available. The most important design criteria are function and materials, and the least would be weight, creativity, and aesthetics.
Ultimately, we came up with 3 different designs consisting of 4 different instruments per design. Based off of the AHP criteria, the weight was assigned, a rating was given to each design and criteria. Design number 1, consisting of a pan flute, recorder, glockenspiel, and allow, are what we chose, and the following are their descriptions.
The pan flute is a wind instrument that is made up of 9 pipes. The pipes have 1 closed end and are cut to different lengths. The different lengths are required to play each frequency in the high voice section of the ASU Alma Mater song. In the next slide, it'll show the equations. To solve for the length of pipe, the equation is listed as 1.2. Since this is a pipe with 1 closed end, we have to use the end correction formula listed as 1.3. And these are the equations showing the actual length of each pipe listed in green. This is the orthographical technical drawing for the pan flute showing the top, front, and right side views and all 9 pipes as well as their different lengths listed at the bottom. The materials list are PVC pipe, 550 cord, styrofoam, paint, and glue. The total cost was $13.47, and additional tools were the reciprocating saw, some scissors, and a ruler.
All right, the recorder itself is also part of the flute family. Traditionally, it's made out of a hardwood material, but I have chosen a PVC pipe due to its readability and cost efficiency, as well as a piece of red cedar wood dowel due to the fact that it has a very robust characteristic when it comes to high moisture contents. The next slide itself is dealing with the calculations I utilized to find the overall length. On the far right column, I had to switch everything to meters to inches. As you will see on the next slide, my overall length drawing is 19 inches, and I have given good dimensions for every hole that I'm going to have to utilize to hit those notes. On the next slide, I do have a materials breakdown, roughly $2 and some odd cents. It's very cost efficient for a piece of instrument.
My instrument is the glockenspiel. It's made of 7 aluminum bars supported by 2 rubber bands and 4 nails each. The rubber band supports must be 22.4% of the length from either end. The materials I am going to use are aluminum bars, rubber band, nails, wood, paint, and a mallet. The total cost for me is $14.59. Additional tools that I'm going to need will be a hammer and a miter saw. Here's the equations that I use to calculate the length of my bars. Essentially, we're going to take m squared, multiply it by pi, multiply that by k, and the speed of sound through the bar. We're going to divide that by the product of 8 times the frequency that we're trying to build the bar length for. M is a constant, 3.0112 for simply supported percussion bars, and K is a constant based upon the bar thickness. So it's the bar thickness divided by 3.46. I here are the frequencies that I have to hit in my portion of the song. I used MATLAB to calculate the length of each bar and how far from the two ends the bar needs to be supported by the rubber bands. Here's my 3-view orthographical technical drawing of the glockenspiel. The overall length is going to be 10.2 inches, and the overall width is 9 inches. And the height is a little bit more than 3 inches.
So my piece of the design was the lyre. Below is orthopedic drawing, orthographic technical drawing for the lyre. I plan on making it out of a tissue box with guitar strings attached to rulers implanted inside of the tissue box. It's kind of unique because each string will have a set frequency based on the tension, and the tension can be changed with a paper clip on one end to twist the string. So the design features, the string instrument has a set number of string. Each string will be the same length. Each string is set to a specific frequency.
Next slide.
So budget and materials list. So below are some of the materials, and the total cost is $8.99. My materials include wood ruler, hot glue for the wood ruler, and paper clips for the strings, guitar string, and the tissue box. The main price comes from the guitar string. The design justification. So below are the following equations to see if the string with the length of 6 inches can handle the tension for the required frequencies, and it can. And then you can calculate the exact tension required to meet the required frequencies. So I completed all my calculations in MATLAB. I did not use a vector. Instead, I just changed the frequency as it went on. All the frequencies that had to be hit were between 97 and 195 hertz. And then I just did that for each frequency required, and that's what I will adjust the strings to. In summary, design number 1 meets all the specified requirements, including the budget, materials list, and any other constraints that we have. Design number 1 also outperforms the other designs in the design criteria department. So its function, all these designs were based purely out of functionality first, and that's our main priority. Lastly, design number 1 is the solution to our problem. This design perfectly fits into the box and will be able to play the entire song that was chosen. And below are our references.